Question 12 on the 2020 PSAT exam, level intermediate. And I would agree this is level intermediate. Even when I was at the age of taking the SAT, I always got confused with these types of problems. So hopefully, with me working through those problems and teaching it now, I can give you a good explanation because I got stuck with it as well. So hopefully my explanation can help you if you're stuck with it. Okay, so let's see what it says. Timothy can paint 2/7 of the wall in an hour. Jean can paint 1/3 of the same wall in 1 hour. If Timothy and Jean, working together at the respective rates, can paint the entire wall in T hours, which the following equation represents the situation? Which one is it? Okay, so here's the concept that we need to know. Quantity equals rate times time. I tell my students to memorize this phrase, this equation. Okay, and we memorize this because this is what linear models are all about. Y equals mx. Okay, y is the quantity, m is the rate, the slope. Think about it, rate, slope, yeah. And x, or you can think of it as t instead, is time. Okay, quantity equals rate times time. So let's think of some examples. Distance equals rate times time. You might have memorized that. So distance is the quantity, rate is the speed, time is the amount of time it took. So some units as an example to solidify the idea. Distance you can measure in miles, right? A speed could be miles per hour, and then you go for a certain amount of hours. So when you multiply these two units together, look how the hours cancel. You're left with miles. Another example, let's say you're working. You have an hourly rate, wage. Yeah, so like $10 per hour. And you just multiply it by how many hours worked to get your total payout, your salary. So dollars equals dollars per hour times time. So notice time cancels, okay? So quantity equals rate times time. And then if you remember our linear model in slope-intercept form, y equals mx plus b, b is just the initial value. So we understand it as when x is 0, x is time, remember? No time has passed, y equals b. So that's why it's called the initial value. All right, so I went over this in a different problem, but hopefully if you didn't watch that, this was helpful. Now, let's go over the solution. So quantity equals rate times time. What's the quantity in this particular scenario? It's the amount of walls. Okay, and we're interested in the quantity of one wall, actually. We'll use that in a bit. The rate is how fast someone paints the wall. Okay, so what's Timothy's rate? It's 2/7 of a wall in 1 hour. So that's why I wrote over here, 2/7 of the wall per 1 hour, or 2/7 walls per hour. And then Jean's is 1/3. So 1/3 walls per hour. Okay. We can combine rates. Okay. So think of Timothy and Jean as one singular person because they were interested in if they work together. So it's like that one singular person. Let's combine their rates. Okay. So when you combine them, and it makes sense when you think about the units. You can add same units together. Things with the same units together. So 2/7 plus 1/3 is just 2/7 plus 1/3 watts per hour. I didn't bother simplifying because we don't need to here. So the combined rate is 2/7 plus 1/3 T. Okay? Or 2/7 plus 1/3. Sorry. No T. Let me get rid of that. That's the combined rate. So now putting the pieces together. So I plug this into the rate. Okay. And we're interested in the quantity of one wall. And we're interested in how much time it takes for that one wall with the combined rate of them. That's how we put the pieces together. Hopefully this is helpful to understand, okay? And then just to get a matching answer, we just distribute this T to both the 2/7 and the 1/3. And the best answer is A as a result. Again, the key concept is quantity equals rate times time. And then in this particular case, we also can combine the rates. Think of the two people working together as just one singular person with one rate.